Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's easy puzzle is called Six Whisperer Palindrome by Wook, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, we get a column here, and box. Digits along marked diagonals do not repeat, so similarly to the normal Sudoku rules, the digits 1 through 9 must appear once each in every diagonal that's marked. And that's the two main diagonals. Six whispers. Adjacent digits along the dark green line must differ by at least 6. So this is basically the souped up version of the German whisper line. Instead of the difference being 6 between digits, it has to be, since instead of the difference between 5 being between two digits, it must be 6. So for example, if this were 3, this would have to be a 9 because that's the only digit that's 6 away, at least 6 away from a 3. And that's how six whispers worked. And those for every dark green line. Palindromes. Digits along a gray palindrome line read the same forward as backwards along the line. So basically, in essence, basically it reads the same forwards, so along this line, as the same backwards along those lines. And there are certain characteristics of that that sort of takes into account. Thermometers. Digits on a thermos are strictly increasing from the bulb to the tip. So basically, that means this cell is always greater than this cell is less than this cell must be less than that cell. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so along a six whisper, in addition to a German whisper line, you always alternate between low digits and high digits. For the six whisper, it's 1, 2, 3, and 7, 8, 9 being the low and high sets, right? So in this set, you know you have at least 5 of 1, 2, 3, 7, 8, 9. So we'll alternate by just choosing a random set, making this pink, this orange, this is pink, this is orange, this is pink, and this must be orange. Okay. In addition, let's see. Let's just mark the palindrome. So we know because this is A, this has to be an A also, right? Because it has to read the same forward as it does backwards. So therefore, these two must be the same digit. This is a B, B, C, C, D, D, E, E, and these are the same, F and F. Okay. What else do we know? B is on a palindrome. We know... What else do we know? There's two pinks here. Therefore, and there's also one pink here. And again, each set in a six whisper line can only be 3 digits. So we know all the pinks are on here. What we don't know is what the remaining digits must be either non-set numbers or orange, but we don't know which one is which. Okay. This is one of each. Let's just make D, I don't know. We know there's an orange and pink here. We're not sure which one this is, though. We do know that these two are the same set. So I guess we'll make this yellow and green. So this is yellow and this is green, right? There must be one each of this set. So one yellow and one green here, which means we have, in row 2, we have 3 yellows already, which means this can never be yellow. So therefore this is green, which forces this to be a yellow. Therefore we know this is yellow. What does that mean? I'm not really sure. One of these is orange. Oh, we know B is on a 6 whisper line. We have already 4 others, and E is on a 6 whisper line. Therefore, we have all 6 on the 6 whisper line, or that can be on a 6 whisper line, which would be 1, 2, 3, 7, 8, 9, accounted for. So B is 1, and all of these are 1. And these we know specifically are 2 of each. So 2 of them are green and 2 of them are yellow. Therefore, this must be a green because we already have 3 yellows. Therefore, B is a green, and therefore this one is a yellow. We don't know anything about these. D can be green or yellow, we're not sure. So say, okay, so we know these are all, so F has to be a 4, 5, 6. These have to be 4, 5, and 6. So therefore, this is at minimum 4 and 5, and this is maximum 5, 6. F is also a 4, 5, 6. This is a green. If pink is the same as green, what would that mean? So if pink were the same as green, then these would be yellow, right? Then also, these would all be yellow. So this would be yellow. This would have to be green because it alternates between sets. 1, 2, 3 has to be next to 7, 8, 9. This is then green. This is yellow. This is green. And this is yellow. Which would mean that these 3 would have to be 4, 5, and 6 if that's the case. Oh, that's also another thing. We have all 6 digits that can be on the 6 whisper line in row 8. So the rest of the digits must be not of those digits. So it must be 4, 5, 6 here, and this must be 4, 5, and 6. So this has to be at least 5 through 9. But we're not sure which. We know D is on the line. So one of the E's then has to be this E. Right? Because where exactly is E on row 2? It cannot be any of these cells, and it cannot be C. So it must be one of these 2 cells. B, where's B? B cannot be here, cannot be here. So it's one of these 4. A is not here, but not here. It could technically be E, or it could be any of these letters. So it could be E. It's unlikely to be E, though. Say it was E, actually. Then we know this was a yellow. And you have 2 yellows here. Ah, it cannot be. We have all 6. So this can never be A. So we have all 6 digits on the 6 whisperer line, right? It's these 4, and then B has to be on it, and then obviously D does because that's a 6 whisper line. So the rest of the digits must be 4 through 6. Therefore, A must be one of A cannot be this one. Therefore, this is A. So A is a 4 or 5. What is C? C cannot be D or E, so it can't be these. It can't be any of these. It cannot be B. It could be A. So it could be A or F or this number. We're not sure which. Yeah. Could be this number, right? B cannot be here or here. Okay, do we have anything else? Where is this number? It could be B, it could be D, or it's one of these digits. So one of these digits is E. The other digit must be one of these two. We're not sure which, so. D can't be here, D can't be here. How many 6 digits do we have here? We don't have enough. Okay, so we know F is not. Okay, so let's just mark them as gray. We know the ones that are not. So F cannot be a. It has to be a middle set, I guess, which we're gonna mark as gray right now. Um, 2, 3, 4, 5. We have 1, 2, 3, 4. This is obviously middle set. This is a middle set. This is a middle set. F is 1 also, so this has to be the non-F one. So we'll say this is G. This then has to be F. So then we have a G somewhere. We have an F. F is one of these two cells. F has to be one of these 3 remaining cells. We're not sure which. A. What else can A? A cannot be here. A could be C. So it could be this one. A cannot be here. F cannot be D, and F cannot be C. So it can't be any of these. So F could be any of these 4. What can A be? We've already tried that. A could be C, so it could be any of these 3. A could be any of these 4. A could be any of these 4. Oh wait, A cannot be on the line, on the diagonal. Oh, interesting. How many grays do we have here? Don't know. We have 1 here, 2, 3, 4. So we don't know about that. We don't know about that. Hmm. Well, okay, what can these specifically be, right? This has two unique digits next to it on a six whisper line, so it cannot be 3 or 7, because 3 and 7 can only be next to one unique digit on a six whisper line. So that's 3 can be next to a 9, and 7 can be next to a 1. So this is 1, 2, 8, 9. These are also 1, 2, 8, and 9. Interesting. These are next to two unique digits, so this is 1, 2, 8, 9. This is next to two unique digits, so it's 1, 2, 8, 9. This is all. These two are also next to unique digits, so it's 1, 2, 8, or 9. Therefore, the pink must be a 3 or 7. This is also next to unique digits, so it's 1, 2, 8, or 9. So one of these two is pink. We're not sure which. This could be any of them, though. This could be any. This could be any. This is next to two unique digits, so it's 1, 2, 8, or 9. This is also next to two unique digits, so it's 1, 2, 8, or 9. This is next to two unique digits, so it's 1, 2, 8, or 9. And then we can alternate between these two. So this is the same as these two. Only one of them can be a 3 or 7. So therefore, what's the last one? It must be a 3 or 7, which means this must be a 1 or a 9 to be with it. Since this is a 1 or a 9, oh, this also has to be a 1 or a 9 to be next to the 3, 7. This cannot be 1, 9 then. This has to be the 2, 8. 2, 8 obviously has to be next to 1, 9 and 2, 8. So, can this ever be 3, 7? If it's the opposite color of this one, right? So these two are the same. Then this one is the same. Otherwise, this is 3, 7. Um, this is 3 or 7. So, you kind of need another coloring. I'm just gonna make it red and blue. So these three have to be a different color than this one. So these must all be blue. These then are red. So that works, whichever one it is. Ah, so then the blues cannot be the same as the oranges then, right? Because there cannot be 4 in a set in 1, 2, 3, or 7, 8, 9. So therefore we can make blue essentially orange. So the blues have to be orange, and the reds have to be pink, right? Because we need 2 of each. Therefore, D cannot be green because we have 2 pink here and 2 orange here, right? Because of that, one of them has to be one color and the other one has to be the other color, which means since this is green, this has to be yellow, which means this is green, this is yellow, this has to be green. Okay. Here, then, in column 6, we have 1 of each color in these 4 cells. So therefore, this is 2 each. This must be 3 oranges. This can't be orange, then. Well, what can it be? It can't be pink because we have 3 pinks in box 5. Therefore, it must be a non-set. So one of these must be orange. We're not sure which. Therefore, this must be pink, then. Because we already have 3 grays, so 3 non-sets in column 6, and we have 2 each here, and this is orange, so this must be pink. Therefore, one of these is pink. We're not sure which. This cannot be the orange 1, 9, so this has to be 2, 8. Therefore, this must be the orange 3, 7, right? Because the orange 1, 9 is already here. Therefore, this can't be 1, 9. This couldn't be 1, 9 either, so therefore it's 2, 8, which means the orange 3, 7 has to be here. So this is 1, 2, 8, or 9. This can't be 2 or 8. This has to be the 1, 9 because of what's remaining. This is the orange 3, 7. We have, so therefore B must be essentially a 1, 2, 8, or 9, and the D must be a 1, 2, 8, or 9. Therefore, we have 3 greens already. We know B is a 1, 2, 8, or 9 because it cannot be either 3, 7 because of the 3, 7 pair. Therefore, both of the greens must be 1, 2, 8, or 9, and this must be the 3, 7, which forces this to be the yellow 1, 9. This can't be the yellow 3, 7, therefore the D must be the yellow 2, 8. Because the 1, 9 must be next to the 3, 7. Therefore, the E is the yellow 3, 7, which must be next to the green 1, 9. So this can't be 1, 9. Therefore, this is B. So the B is the green 1, 9. So it's the same here. We know this has to be then 2, 8 or 3, 7 for the yellow. Therefore, this also has to be the green 1, 9 to be next to the 3 or 7, that 3 or 7 yellow that's next to. Okay. We know, let's see. This we don't know what it is. This cannot, okay, so the orange 1, 9 is here. This is a green 1, 9. The green one, therefore there's a 1, 9, 1, 9 pair. And in addition, we know that the green cannot be the same as the orange. Therefore, the oranges must be yellows. So these must be yellows, and the pinks must be greens. So because this is green, this cannot be 1, 9 because it's eliminated by that 1, 9. So this is a 2, 8, 2, 8. This can no longer be 2, 8. This has to be a 1, 9. This sees both the green 1, 9 and the yellow 1, 9, so this cannot be either. This also sees the green 1, 9 and the yellow 1, 9, so it cannot be either. And in addition, it has to be next to a 2 or an 8. Well, the only digit that could be next to a 2 or 8 is another 2 or 8. That if it's not one of the 1, 9s, it can't be 3 or 7. This can't be 3 or 7, so that we know this is also a 1, 9. Okay, so this is 2, 8, 2, 8. This is also a 1, 9. And it cannot be the yellow one, therefore this must be the green one. So this is green, which makes this a yellow, which makes this green. This cannot be the yellow 2, 8, so this must be the yellow 3, 7. So this is not E. This can't be the yellow 3, 7, so now it's the yellow 2, 8, and this is E. Let's see. This can never be 2 or 8. Cannot be 2 or 8. Because we have a 2, 8, 2, 8 pair in column 2. This is not the yellow 2, 8. It's also not the yellow 1, 9, so it must be the yellow 3, 7. In addition, we have all 3 yellows on the negative diagonal. So therefore, yellow cannot be on the negative diagonal. Where is the last yellow in box 5? It must be here. So this is not F. This is the yellow 3, 7? No, we don't know which one it is. It's either 3, 7 or 1, 9. This can't be 3, 7 because of this. Therefore, this must be a 1, 9, which makes this a 3, 7. Therefore, this is an F. This can't be F anymore. No. This cannot be the green 1, 9, therefore it's the green 2, 8, which forces this. Oh, we already knew this one because of this. This has to be next to a 1 and 9. Next to it must be next to a 3, 7. Okay. This last one is a green 2-8, so therefore the green 3-7 is one of these two. We're not sure which. The C cannot be any of the greens. The C cannot be an F, and it cannot be the G. So C can't be any of the greens because it sees all three of the green cells here. And it cannot be any yellow because it sees all the three yellow cells here. And it can't be F and it can't be G. C must be equal to A. So C is the same as A. Oops. As A, and it's gray. Therefore, where can A be now? It's still kind of wide. This has to be F. This then has to be G. Which means this one has to be green. And this one has to be green. Because otherwise we don't have any other greens on the negative diagonal. So this cannot be F. This has to be specifically the 2-8 green. Which means this is the 3-7 green. Well, where else can the 3-7 green be in row 7? None of these, because of these two cells. It can't be this one because of the 6 whisper line, and this one has to be the same as this A, which is in the palindrome. Therefore, this is the green 3-7. 3-7. Which means this has to be a G, and it is not a middle. It's not a, it's middle digit, sorry. Okay. F is one of these two. F is one of these three. G is also one of these three. F cannot be on the diagonal. F can't be here. So F has to be one of these three also. This is the last green, and it has to be a 3-7. What else are we missing? Green 1-9 cannot be on this cell, on any of these three cells. It also cannot be along here because it's here. So it must be one of these two cells, and it can't be that one. Therefore, this must be the green 1-9. Two 8. The yellow 2-8 cannot be this digit. It cannot be any of these digits. And it can't be this digit because of that 2-8. Where can it be on the positive diagonal? It has to be here. So this is the yellow 2-8 here. We have now the yellow 1-9 remaining. And that could be here or it could be here. Either one works. We have a 1-9-1-9 pair here. We have a 3-7-3-7 pair here also in row in row 7. So 7 and 9 both cannot be here. Now this is 4, 5, and 6. The 2 cannot be any of these cells. So this obviously must be a 2, which means this can never be 2. Therefore, it's an 8. Therefore, all the greens are essentially the highs. So the greens have to be high. The yellows must be low, which means this is all the, all of these 2 8s and red are now 8s. So these are 8. All the 1 9s that are red must be 9. All the red 3 7s are obviously 7. And therefore these are 1. These must be 2. And these must be 3. Let's see. This is 2. 8 cannot be here. Where can the 8 be? In row 7, it has to specifically be here. So this cannot be 6. These are all the gray cells. So this is the gray. This is a high. This can't be the 2. Therefore, this must be the 2. And it's the last low. Where can 9 be? In box 9. It has to be here. So this is the 9. These must be actually 3 lows. And this can't be 2 or 3. Therefore, this is 1. This can't be 2, so this must be 3, which makes this a 2. And I think that's... No, it's not all the 1s. The 1s could be here or here. The 2s are all set, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. What about the 3s? The 3 are not set, but this has to be 3. And the low. Where's the last one? This is 1, 2, 3. This has to be a 3. Which means that's the low. 1 has to be one of these 2 cells. 1 can be any of these 2 cells. So that's not limited. Okay, what about 9? 9s, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the 9s are counted for. 8. 8 has to be here. So this is an 8. Just by Sudoku, these 2 are eliminated that way. This is eliminated by that 8, and this is eliminated by that 8. That's the only remaining cell. So the last 8 then has to be here. So those are all the 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. What about the 7s? The 7 cannot be here because of this 7 can't be here. Also, this has to be an F. And this is a gray. Where's the last 7? 7 can't be here because of this 7, so therefore this must be a 7. The last remaining 7 cannot be here, and it can't be here in box 1 because of these 7s, therefore this must be a 7. And that gives us the last remaining 7 being here. Because once you have 8 of them, you should be able to specifically decipher where the last of a digit is. It can't be any of these 2 because of these 7s. It can't be this because of this 7, therefore it must be here. This now must be the A non-set, right? 4, 5, or 6. Therefore, this is not A. This can't be A. Where is A in box 7? It has to be this cell. So this is an A. Where's the F now in box 9? It has to be here because it can't be either of these. This is an F. This can't be A, so this is G, which makes this an F. And therefore, this is an A. This is G. F is greater than G. We don't know what else, though. One of these 2 is G. So we have 1s remaining, I think. This can't be F anymore, therefore this is an F. Um, this is a 1, so this can no longer be 1. 1 can be either of these two. 1 can be either of these two. 1 cannot be here, so this must be a 1. Therefore, this is a G. This can't be G. Therefore, this is F. This is G. One of these is 1. Okay, this has to be a G. This, what's along here, has to be an A, because that's all that's missing from the positive diagonal, so this is an A. This then has to be a 1, and is low. This must be a G, and this has to be a 1. So this is a low, this is a gray. Okay, so G is greater than A, which is less than F. So F must be the 6. So F is the 6. G must be less than, or that, but greater than A, so it's a 5, and A must be the lowest one, which is a 4. And that's how you solve it. Yeah, pretty straightforward. I like it. It reminds me of coloring exercises, which is always fun for me. Yeah, I like using the letters for palindromes because palindromes you don't have a guarantee that different colors are this. If you use colors, you don't have a guarantee that the colors are different, right? Like this one, like the A and the C being exactly the same, um, made it easy to transfer immediately. It's just say, oh, C is specifically A, so therefore we could just make it. Whereas colors feels a little bit, I don't know. It doesn't feel as easy to to change those. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.